So the last method we're going to use to solve a set of simultaneous equations is known as solving by elimination. So the time we want to use this method is if each equation is given in general form, because it would be tedious to try and use substitution to try and solve these ones, because you'd have to rearrange the equations first. Once you've rearranged it, then substitute in, so it becomes too difficult. So when we're solving by elimination, basically all we're trying to do is have the coefficients of either the x and y as one as a positive and one as a negative, because if we add the two equations, for example here you can see if I have negative 2y and I add 2y to it, I'm going to be left with 0, so therefore I'm only left with one variable, so I can find that unknown variable. So start off by labeling your equations. This is equation 1, and this is equation 2, and we're going to add 1 and 2. So you can see if I add the 5x and the 3x, I'll get 8x, and then minus 2y plus 2y is just 0, and that is equal to 17 plus 7 is 24, and then it's just a matter of solving for x. So we'll divide both sides by 8, so x will be equal to 3. So I've solved for x, but I still want to know my value for y, so now I just need to substitute this value into either one of those two equations. They've substituted x equals 3 into 1, so I'll just stay consistent with them. Substitute x is equal to 3 into equation 1. So you can see we have 5 times 3 minus 2y is equal to 7. Now it's just a matter of rearranging to try and get y by itself. So 15 minus 2y equals 7. If I subtract 15 from both sides, I'll be left with minus 2y is equal to minus 8. And then if I divide both sides by negative 2, y is equal to 4. So the solution is x is equal to 3 and y is equal to 4. Now once you've found a solution, you can do a quick sanity check. So we can substitute these values into either one of these equations, and if they satisfy the equations, then we can see that we have determined the correct solution. So if I substitute each of those values into equation 1, you can see I'll have 5 times 3 minus 2 times 4 is equal to 50, or it should be equal to 7. So on the left hand side we can see that 15 minus 8 is equal to 7 and 7 is equal to 7. Therefore the left hand side equals the right hand side. So we've shown that our solution satisfies the equation. Now example 11 is slightly more difficult, because you can see if I add these two equations, once I've added them, the y terms will not add to 0. There will still be a y. So we have to try and manipulate the equations in such a way that when we add them, they will become, this one needs to be positive 12 and this one needs to be negative 12. Or we could do it with the x's. We could make this, say, positive 6 and this negative 6. But I'll stick with trying to change the y's. So basically all I'm trying to do is find some type of value that I can multiply each of these equations by. So start off by labeling your equations 1 and 2. So I can see if I want to make this positive 12, I'd have to multiply it by 3. So I'd have to multiply the entire equation by 3. Whereas if I wanted to make this minus 12, I would basically just multiply each term by 4. So we'll start off with equation 1. If I multiply each term by 3, this would become 9x plus 12y is equal to 6. So this was equation 1 multiplied by 3. And I might call this equation 3 now. And then here, if I multiply each of those terms by 4, because then I'll get a negative 12 here, this will become 8x minus 12y is equal to 28. So I've multiplied equation 2 by 4. And I'll call that now equation 4. So now you can see if I add the two equations, positive 12 plus minus 12 is going to give me 0. So I'm just going to be left with x terms. So adding 3 and 4, you can see 9 plus 8 is going to be 17x. Positive 12 plus minus 12 is just 0, and that's going to be equal to 34. And then it's just a matter of simplifying the equation. Let's divide both sides by 17. So x is equal to 2. So I've found my value for x, and now it's just a matter of substituting this value in to either one of our two equations to find a value for y. So substitute x is equal to 2 into, I'll substitute it into equation 1. So I'll get 3 multiplied by 2 plus 4y is equal to 2. Now it's just a matter of simplifying. So 6 plus 4y is equal to 2. If I subtract 6 from both sides of the equation, I'll get 4y is equal to negative 4. And then I just need to divide each side of the equation by 4. So y will be equal to negative 1. So therefore, the solution is x is equal to 2, y is equal to negative 1. And again, you could do a sanity check and substitute that solution into either one of the equations. And if we've done it correctly, we will see that the equation is satisfied. So if I substitute it into 1, 3 by 2 plus 4 by negative 1 is equal to 2. So you can see 6, 4 times negative 1 is minus 4, is equal to 2. 2 is equal to 2. Therefore, the left-hand side is equal to the right-hand side. So we can see that our solution has satisfied the equation, and therefore our solution must be correct.